I scroll past the title? So kids normally start to panic a little when they're looking at this. If you get out your unit circle and your purple sheet, it's not going to be as frightening. Alright, so when it comes to solving trig functions, number 1 says don't ever divide by the trig function. Why should I not divide by it? What happens if it equals 0? Yeah, that's illegal. We can't divide by 0. And I say that as somebody who got yelled at for doing it myself. And then I was like, oh, yeah, forgot that that's a possible thing. Alright, so most of these are all going to start off with solving them on the interval of the unit circle. Alright, so I would write that in. Actually, every single problem we're doing today follows the exact same instructions, so that makes life a lot easier. Ready? So, let's actually start off with the one on the left. Anytime you've got sign it on two different sides of the equation, move them so they're on the same side, and get your numbers so they're by themselves. So, I'm going to add sine of x to both sides. And because I'm lazy and I want to do this in one step, I'm going to add square root of 2 over here. So I'm without the square root of 2 on the same side. So I'm left with 2 sine of x equals the square root of 2. What else do I need to do to get sine of x by itself? Yep, divide by 2. And remember how I kept harping about you better know your unit circle? Your answer is, where on the unit circle does sine of x equal root 2 over 2? Pi over 4. Yep, 3 pi over 4. So the vast majority of the time, you will always give your answers in radians. But if you knew degrees and or radians, I'm cool with that. Now, the one on the right, I still have not found this one right here. This thing, I finished that one. But this sine of x plus 1 equals cosine of x, I still have not found like a good way of doing it besides this table way that I've figured out. So whenever you see a sine of x and a cosine of x, you're comparing x's and y's, right? So that tends to make life just a little bit difficult because, well, number one, if it's a pi over 4, a pi over 6, or a pi over 3, if I add those two together, Do they add up to equaling anything pretty? No, it's like 1 plus the square root of 3 over 2. That's not going to work out real well. So we're ignoring everything except our main quadrantals. So 0, 90, 180, 270. All right, so we are going to make a little, well, I'll put x here. We'll put sine here. We'll do cosine of x here. And then that final column is it a solution? Bless you. So if I start at x equals 0, what is the sign at x equals 0? What is sine? 0. What is cosine? Okay, so look right here. I've got sine of x plus 1. So what is 0 plus 1? Does that equal 1? Cosine of x equals 1. Because remember, it's 0 plus 1 equals 1. That's a solution. I am happy. Like, this is legitimately the best way I figured out how to do it. And it's been 8 years. All right. My second one is going to be at pi over 2. So what is the sine at pi over 2? What is the cosine there? So what is 1 plus 1? Yeah. 1 plus 1 is 2. Does 2 equal 0? Like, this is all I've got for work. This is the only way that made sense in my little brain. All right, do you guys want to check the last two? I'll put them up there for you. So I need you guys to check pi and 3 pi over 2. So you're just going to fill in those last two rows. All right, chat it over with a neighbor. Let's see what we got. So, did pi work? No. Because I've got 0 plus 1 is 1. 1 does not equal negative 1. So that's a no. And then I've got negative 1 plus 1, that's 0. 0 equals 0, so I'm cool there. So really, my two answers for this one are at 0 and 3 pi over 2. Where am I getting what? Unit circle. These are your x's and y values at these radian values. I'm just trying to see which one will work when I plug them back into my equation. Okay. All right. Can I scroll? Yes? All right. Okay. Do you guys want to try this one with your neighbors? It's not too bad. Give it a whirl. start with today's stuff and work your way backwards, okay? So you're just doing volume. All right, do we think we got it? All right, so what do we think? Good? All right. I was going to say that's about as bad as it gets, but there's a couple with factoring. Yeah. Like this. So we're actually going to use a Pythagorean identity on this one. And then the crying stops. All right, we ready? So I said we were using a Pythagorean identity. So which one are we using? Cool. So I'm actually going to replace this entire stupid thing with 1 plus tangent squared. Any ideas of what we will do next? Yeah, I'm going to distribute that 3 through, and I'm going to try and condense down as much as I possibly can. So I've got 3 plus 3 tangent squared of x. What happens to the tangent squareds? They combine. Yeah, I just am left with a single tangent squared of x, and then 3 minus 4 is a negative 1. Set it equal to 1. So I've now got tangent squared of x equals 1. When you square root this, you are left with tangent of x equals both positive and negative 1. Not all the tangents. There's 4 very specific tangents. Which ones are they? Pi over 4. You meant all of the tangents that are over 4? Yeah. So remember how everyone looked at that one and kind of panicked a little? Not as bad as we thought. All right. We've got this next one with cosine. I think it's this one and one more, and then we're done. Any ideas how we want to solve this one? Are they all using the same trig function? Yes. Could I maybe factor it? Bless you. Are we a little panicked about factoring it with cosines? Do we want to use like a u sub? No? You're lazy? Alright. It's just getting rid of icky crap. And if you don't like a u, you can make it an m. 7th period wanted it to be an M. So they just did this. It does sound like 7th period. So this factors into 2 cosine of x plus 1, and then it's cosine of x minus 1 equals 0. Now those equal 0, right? Can't I split them and solve them that way? So I've got 2 cosine of x plus 1 equals 0. So cosine of x equals negative 1/2. And then the other one is cosine of x minus 1 equals 0. So cosine of x equals 1. Can I solve for those trig values? So this one is at x equals 0. This one over here is at x equals 2 pi over 3. And 4 pi over 3. Do you guys kind of see why I was like, you have to know your unit circle? I mean, I could maybe give you guys a little blank circle that you can kind of draw on. That would be okay. I was just going to do a circle with the quadrants and then 3 dots in between. But, okay, so now that we've done this one, was it still horrible? Don't panic. Move everything to one side. Yeah, tomorrow I'm going to do a little bit of notes where we're solving not on an interval. So it's the same crap, but it's got like a minor change. And then Friday will be an all proving task day. So today you guys will be getting back any and all proving tasks that are in the box. I've already got Unit 10 Proving Task 3 in the math lab. But I have a third version of Proving Task 1 from Unit 10. I will have all of those, like, either in here or in the math lab ready to go. So if you guys want to take them on Friday with Miss Johnson, you've got them. Yes, and it's only on proofs. Just proofs, not solving. I think the one for solving is, like, next week, Tuesday. All right. We panicking still? Stop. Sine squared of x minus 2 sine of x equals 0. I'm lazy and I always want everything over on the left. It does look better that way. And then I'm going to actually factor out a sine of x. So I'm left with sine of x times the quantity sine of x minus 2 equals 0. I was going to say, now it's not as bad, right? So I've got, where does sine of x equals 0? 0 and pi, right? Yes, no, kind of. Does sine of x ever equal 2 on the unit circle? No. So this one is an extraneous solution, simply because it is not on the unit circle. But that's it.